Hola, mi clase. Today we are doing 4.4 linear inequalities. So they're going to be still straight lines, but we're going to have an added extra part because we're dealing with inequalities. So a linear inequality in two variables, so that's our x and our y, is a set of points that represent all solutions to the inequalities. So a solution of a linear inequality in two variables, again, that's x and y. The linear inequality is divides the coordinate plane into two halves. So our line cuts it into two halves by a boundary line where one half is our solution and the other half is not. Okay, so this will make more sense, but basically we're going to draw a line. It's going to cut my coordinate plane in half. One half is going to be the answer and the other half is not. So we have this inequality, y is less than x minus 1. So what we do is we do need to look here first, because if it's less than or equal to or greater than or equal to, it's going to be a solid line because it's equal to. So just like when we did inequalities, we had open circles and closed circles. Graphing a line is the same way. An equal to means a solid line because it's all included, equal to. A non-equal to is what's going to be a dashed line because it means that line is not included. So we have to kind of, in a sense, open it. Okay? So we're going to graph this just like this was y equals mx plus b, right? So it's almost, we initially just graph it like it's this, and then I'll tell you what we do with this inequality part. So let's just go graph this line. So we go to -1. And then we do our slope, which is 1 over 1, right? Because it's a whole number 1. So I'm going to go 1, 1, 1, 1. And I'm going to do all of them that can fit on here because I have to split my coordinate grid in half. So that's why the other half needs to be graphed as well. All the way down to here. So then I'm going to connect it with a line. I'm going to let it be a solid line because it's equal to. All right, so there's my line. Now, once we've graphed the line, we then have to pay attention to this. What we want is all the y solutions to be less than or equal to x minus 1. So this line represents the equal to part. Okay, this is where y is equal to x minus 1, right? So if we plug in 1, 1 minus 1 gets me 0. Well, that point right there is 1, 0. Now, that's the equal to. I want it to be less than that. Well, everything that's less than that is down here, right? This is -1, -2, -3. That's less than 0. So that's everything down here. Same thing like if I look here, this is at 3. So if I plug in 3, it's 3 minus 1 is 2. That's where I'm at. Oh, 3 minus 1 is 2. But I want everything less than that. And so on, right? 6 minus 1 is 5. That's where I'm at. But I want everything less than that. So what that means is all of this is also my solution. And so what we do is we shade it in to the best of our ability. Because this is equal to, and this is everything less than that. All right, let's do another one. So we're going to do a story problem. It says a science club sells t-shirts and keychains to raise money. How many t-shirts and keychains could they sell to meet, so equal to, or exceed, that's a greater than, right? Their goal. They want it to be more than their goal. So I'm going to get a grid on here really quick. Oops, hold on. Because I'm going to have to graph this. Oops. All right. So they tell us their goal is 500. We want it to be equal to or greater than 500. Okay, so their goal is 500. We want to exceed or meet that goal. T-shirts are $10. So let's go 10x. Let's make this x. And keychains are $2. So we're going to go plus 2y. All right, we'll make this y. Just like our system, but we only have one. Okay, one line. So it's very similar to our systems, right? Standard form. So I'm going to solve this for Y-intercept form so I can graph it. So we minus 10x. We get 2y is greater than or equal to negative 10x plus 500. And then we'll divide by 2. And we will get an equation of y needs to be greater than or equal to negative 5x plus 250. So after selling the t-shirts and everything, it needs to be greater than or equal to 500, and this is how we would get that. All right. So my y-intercept's 250, my slope is 5. I'm definitely going to want to make sure that I can get to 250, but also be able to graph 5s. So down here, I'm just going to make this go by ones. 1, 2, 3, 4, 5. Okay. Oh, I just looked at my solution, sorry. I want to make sure that I have enough. So we're going to actually jump these bigger so that they actually fit. Hold on. Oh my goodness, sorry. All right, let's go by 10s. 10, 20, 30, 40, 50, 60, 70. Just want to make sure it fits on our grid. And then we're going to have the y's go by 40s. So we can get up to that 250. And you know what, let's just go by 50s. That way it'll jump a little faster. So let's go 50, 100. It's not too much more. 150, 200, 250, 300. That way I can get my y-intercept on there. So my y-intercept's right here at 250. Our slope is negative 5 over 1, but I'm going by 50s and 10s. So it's going to be a little trickier, right? So my axes are going by 50 to 10. That's its ratio. But we actually can times, you know, this by 10 and this by 10, and we get our 10 over 50. So every time I go down, it's 50. And every time I go over, it's 10. Well, negative 50 over 10 is exactly the same thing. So down 50 over 10, down 50 over 10, down 50 over 10, down 50 over 10. Now it is equal to, so that means it's going to be a solid line, right? Equal to solid line. Everything that on this line also is a part of my solution. So we would have a solid line. Mine's not perfect. That's okay. And then I want everything to be greater than that. I need everything to be greater. So if I'm at 250 and I want it, right, I plug in 0, I'm at 250, I want everything to be bigger than that. And if I'm at 40 and 50, I need everything then bigger than that, right? Larger than all of these things. So we would shade in the space above this. So everything larger than what we have. So there's your solution to your inequality. Oh, I went the wrong way. Sorry. All right, here we go. So now we have x is greater than or equal to 3. We've done that, right? We pretend just like x equals 3. Well, if I go 1, 2, 3, oh, 3 is the other way. 1, 2, 3 right here. I draw a vertical line. It's equal to, so it's solid. And then I want all the x's to be greater than that. Well, if this is 3, the x that's greater than that is here. And the x is greater than that is here. So it's everything right here. So it's that line and everything else. All right, sorry, I got a phone call. All right, so just want to clarify, it's this line and everything greater. So that's why we shade all of this in, okay? All right, so we pretend this is y equals 2 to graph it, right? So we go to where y equals 2, so it's right here. Now, this is the first time we have not had an equal to. When we do not have an equal to, it means that this line cannot be a part of my solution. So I have to draw a dashed line. It's just like when we did inequalities and we had an open circle. This line is my boundary, but I can't cross over it, and it's not a part of my answer. So we draw a dashed line. Now in this case, we want y to be less than 2. So if we look, here's 2. Well, this is less than, and this is less than, and this is less than, right? This is the direction that less than 2 would happen. And so that means we would shade in all of that. And that would be my solution to y is less than 2. The dotted line and all of this. All right, so here's 3 where we're going to actually write the inequality for these, okay? So we know it's a dashed line for A, so it's not going to be equal to. We know it's going to have no equal to. The nice thing is the y-intercept is 0, so we're not going to have a plus or a minus. Now, it's a little difficult when they draw a dashed line to find where your where your points are. So to make it a little easier, you can actually, oh, that didn't help because I just like made another dashed line, but it's a little thicker, right? So now we can kind of see where these points are. It's right here, and then there's one right here. They make it a little easier for me to then be able to find the slope. So if you need to, for when it's a dashed line, if you need to color it in to just find the points, that's fine. But you need to make sure you know it's a dashed line so that when you write your solution or your inequality, it doesn't have an equal to, right? So we're going to do y, and then my x is, the slope is up 1, 1, 2, 3, so it's 1/3 x, and then there's no plus. So what we now need to look at is y. Am I looking for the y's that are greater than, or am I looking for the y's that are less than? So if I look, this is at 0 and it's pointing towards -2. This is at 1 and it's pointing down here towards 0, -1, -2, and so on. So that means I'm looking for everything. I want all my y's to be less than this solution. So this would be our inequality. It'd be y is less than 1/3 x. It's not equal to because it was dashed. And then everything is less than the initial solution. All right, why don't you pause and try to do B? Okay, I want you to see if you can figure out B. All right, this is going to be an equal to, so hopefully you put an equal to on there. My y-intercept here is at 1, so I know it's going to be a +1. And then if I check my slope, I go down to right 1, so that's a -2. Y, I know it's going to be equal to. Well, this is at 1, and it's pointing towards -2. And this is at -1, and it's pointing down here towards -4. And this is at 5, and I'm looking for everything underneath that, so we should have a less than or equal to for this, because we're looking for everything less than the solutions, right? Everything less than the solutions. So if it helps, you can always draw those arrows so that you know which direction the shading goes as well, but also the arrows then tell me I'm looking for stuff that is less than this solution. All right, so I'm gonna have you guys do this and we'll go over it in class. Consider it your independent practice. I know it doesn't say that, but I'm gonna leave it blank because I want you guys to try it. And then we'll talk about it when we get to class. So here's your things to remember, that a greater than or less than symbol will be your dashed line, and a greater than or equal to and a less than or equal to will be your solid line. Okay, so don't forget that. And don't forget to shade on that independent practice. It's a part of your solution. All right, until next time, adios, mi clase.